So, thank you for joining me in this talk about GraalVM. We'll be talking about cloud-friendly application with GraalVM. I'm Mohamed Ez-zarghili. I'm the GraalVM sustaining manager, basically, working on release and sustaining for GraalVM. This talk was actually planned to be done by my colleague, Alina. She's from Ukraine, but she couldn't make it, but still wanted it to happen, so I'm here as her replacement, and hopefully I will be able to deliver what she wanted to deliver. So if you blame someone on the delivery side, you can blame me for that, actually. OK, so I have these slides set up in a way. If I understand how many of you are familiar with GraalVM, so OK, I think like 30% or something. So I need to do some highlights so more people understand what we're talking about. And then we can go to more specific sections of that. OK, so what is GraalVM? GraalVM is a product from Oracle Labs, right? And the community, basically on top of the OpenJDK or the JDK, which provide three main things, right? So one easy thing is the performance of the JIT compiler that GraalVM provides through a new Java-based compiler that actually is integrated in the JDK itself. The other part is fast startup with native image. Basically, you can create applications that do not require a Java environment. And three is the polyglot VM, which actually allows you to mix multiple languages. And we'll go through different areas of this. So open source on GitHub, GraalVM is an open source product. You can actually put issues in GitHub or submit PRs, ask questions publicly, or build your own versions of images of GraalVM with the parts that you want. It has a board of from the community to decide on some aspect of it. So, as I said, people can use it as a JDK. So what's the difference from the JDK is that the JDK actually used some C++ or C-based compilers, right, like C1 and C2, and with something called the GVM-CI or GVM compiler interface, right? It brought the ability to create compilers using Java. So basically, when you create a compiler with Java, you have another layer of optimization, which means optimizing even the compiler itself, which is a novel thing at the time. And now it has been there for years. And it proved itself as a very good alternative to using C2 by boosting the performance of application workloads. So from a user perspective or a developer perspective or a company, you only need to move from a stock JDK to GraalVM, and then you get a lot of boost in the performance level. So basically, if you have legacy code, right, that you cannot change, or big legacy code, and you want some more performance, you just switch the underlying JDK. If you're into benchmarks, you can go into Renaissance Dev, which contains a lot of benchmark related to GraalVM and other stock JDKs, and the difference between the performance of each of these. Benchmarks from micro level are not always the result, the answer for your optimizations. You always need to try your application workloads on different JDKs and then see the difference between those and then decide what you want to do. So some companies already use this, so it's not like we are saying that you get some performance boost using GraalVM, but multiple companies, earlier Twitter started this at some point, right? And then there was some work from Facebook moving their Apache Spark workloads on GraalVM for a set period, and they saw boost in performance in CPU reduction up to 10%, and more than 5% in CPU and GC pose improvements on their workloads. The other aspects is polyglot. Polyglot is basically, the word is actually polyglot, right? We have fans for multiple languages, for multiple delivery ways, and GraalVM actually tries to provide the same set of improvements to the compiler and tooling to every language. Most of the languages, popular languages, are already included, either by GraalVM, by labs itself, right, by developing the language, or by the community. You can see implementation for Squeak, or PHP, or other implementations. Some companies actually move their in-house languages to use GraalVM so they can benefit from all the possibilities that the platform provides for debugging, profiling, and so on. So GraalVM can be used on top of GDK or on top on Node.js, replacing, for example, V8 with GraalJS. But you can still also run polyglot programs in JavaScript. Like, let's say I have a JavaScript application that I want to use Panda, let's say. So instead of looking for an alternative that is developed in JavaScript, I can just load Panda modules from Python directly and use them directly in my application. This goes for all the languages you can see here. You can mix between them. And the benefits from performance is that all these languages, at the end, they're bytecode. So the compiler can optimize by mixing all the bytecode there and use all the available optimization that GraalJet provides. OK, so we're talking now about basically the cloud. And there are many issues with the JVMs in the cloud, right? Some workloads cannot use the JVM, let's say, because of the memory requirement, because of the size of the bundle. For example, functions or lambdas. It will be very waste of resources to take a lot of your application cycles just starting up the VM, right? So Native Image provides a new way of delivering Java applications that is very fit for the cloud environment. So basically, it allows you to compile your applications to standalone executables. It performs basically an analysis to identify the code reached. So basically, not all the code in your application will be part of the bundle that is optimized or as an executable, but only reachable code, right? And you get from that instant startup. We'll look at how Native Image is set and why it allows for instant startup. You don't have to start a VM first, right? So basically, automatically you start with the application and your code. It's perfect, as I said, with cloud deployment. We'll see more details into it. And there are many, many frameworks now that support Native Image natively. Some of them actually were created to work perfectly with the Native Image. So what happens in a build for Native Image is that we get the application code that is reachable, any libraries that are used by your code, any GDK libraries that are part of the code base or reachable by your code, and then a subset called substrate VM, which handles the work inside the VM, the Native Image. So many people actually call this head-of-time compilation. It's not basically head-of-time compilation because it has an extra layer. You head-of-time compile your program, but also get snapshot of the heap, initialized heap at build time, so you don't waste time when you run your application to initialize anything that you usually initialize a runtime of an application. So it actually moves any code to the text section of the binary and the image heap into the data section. OK, so how to create a native image? Basically, instead of running Java, your jar, or whatever, you replace Java with native image, and you should have, in theory, an executable that works the same way. There are some limitation to this because native image has a closed word assumption about your application with regards to reflection, dynamic code, proxies, and all that stuff. So your application will require some extra configuration to produce an executable if you're going through this type of workloads. For that, we have some tools and to try some simple application, there is a repository in the GraalVM org that has a lot of GraalVM devos using different frameworks and different examples. Some of the frameworks now that basically support GraalVM from the start is Micronaut, which actually removed a lot of the limitations to Java application by not using reflection, by not using some features that make building these application easy. But it's not just Micronaut. If you want to build application with Micronaut, you can go either to the website UI and select what programming language you want, what version of Java, and so on, and then you get a small bundle to start. Or you can use a CLI tool from Micronaut that not only set up your application, but also help you to add some features. For example, if you start with a guide application, simple application, then you want to add Kafka, right? There is a feature that say, I want to see the difference for my code if I want to add the Kafka feature, and it will show you the diff of stuff that you need to change to add that feature. So from startup time, you can see an example from GVM perspective, a small application here. It runs like 3 seconds to start, right? But if you get the equivalent native image, it will be in hundreds or tens of milliseconds for startup, which is very important for some workloads like functions or lambdas. From CPU and memory usage, the memory usage of native image is very, very low. So you will be X times faster, smaller usage of CPU and memory, but that's clear because you're no longer using the GVM, right? And one problem with this is that you also don't get any extra optimization at runtime. And we'll look into that later on for those kind of workloads. So there is some examples of small applications either running in native image and hotspot. Maybe you'll get slides later and you can look at those references. Other frameworks are started to adopt in native image. Hipster is also now can run with native image. The same for one of the most famous frameworks. There's a variant now of Spring called Spring Native that works with the native image and allow you to generate those binaries. Then, for example, in Spring Native, for some example applications, you can see the difference on memory usage, on startup time actually, and size of the image if you use the GVM version or the native one. Okay, so what I want to share is what you can use, make most use of when building native image. What are the things you need to understand? So for cloud loads, we have different kind of setups. People may use bare metal, VMs, or containers, or opt for functions. Then when you look at this environment, then we will need to look at what the best option for each kind of environment. So basically, native image is not the solution for everything. The GVM mode is not also the solution for everything, but it's not a problem all the time. So for virtual machines, we know that most of those virtual machines or bare metal machines, the startup time for the machine itself takes forever, right? And then you're expected to keep running your application for days or months without any restart to the machine. Startup speed is irrelevant because just starting the machine itself will take a lot of time. So like if you take 20 seconds to start up, that's irrelevant to the time that the machine needs to start up. And for memory requirement, this is basically set to allow for application to consume as much memory available in the VM or the bare metal machine as possible. For containers, it's a little bit different. So basically, most containers are expected to run for minutes or days, right? Like restarting the container is not very problematic because it takes just seconds to restart. Startup is a little bit relevant because if the containers runs at seconds to start, your application should not take more than that. And then from memory requirement, it's moderate. You can run multiple containers on the same machine, so they share the memory in the machine. So the requirement is not for them to take over the whole memory that is available in your machine. The difference is in function or lambdas, which basically you're paying for the time that the function is running. So the startup, the lifespan of that function is very small. Basically, some of them in milliseconds or seconds at most. Mostly, it's rare to find any functions that run for minutes. So startup speed is critical because you're paying for the time that your function runs. If your startup speed is a little bit relevant and big, you're paying money for something else and not your application work. And for memory requirement, most of them are limited in memory requirement. So the GVM side spec, part of loading an application in GVM mode, is very significant compared to your function. Now we can measure actually performance in different ways, right? And in JIT mode, if you use the GVM, you're getting more peak performance because you have a lot of optimization at runtime going on. And the same for reduced max latency, but your startup time is slow. The low memory footprint is your memory is big because you're using a lot of it just for the GVM. And then the packaging of your application will include the GVM and not just your application. For ahead-of-time compilation, or basically native image, which, as I said before, it's not just ahead-of-time compilation, but also a snapshot of your heap. The start time is very minimal. The memory footprint is small. The same for the packaging, because you only have an executable that only include the part of your code and the GDK that is reachable. But for peak performance, you're not getting much because your application cannot run optimizations when it's running, right? You already ahead of time compiled the application, so there is no way for you to gain any performance by running the application and getting optimizations. So what's the goal? The goal is to get native image to peak performance and reduce the latency that you get from the JIT. And the good news, you can do that, right? How you can do that actually is run your application in JIT mode, then generate a guide, a profile for the optimization that run on the JIT mode, and then feed that profile to the build process of the native image, and the generated native image will take into account all the optimizations and decisions that happened on similar application on JIT mode. You can also choose which GC fits your workloads. So basically, we have serial GC with small applications. There is G1 GC, which is for bigger loads or heavier applications, and it's only available, I guess, in it's only available in the enterprise version of GraalVM, and there is the option to use no GC at all, which is epsilon. And for some common use, you will be a CLI where you run some command and then exit, and you don't need to collect anything, right, from memory. And the thing is that you can also monitor the performance of your application similar to what you do with the generic GVM application, because support for GFRs is also available in native image. From perspective of loading your apps in, let's say, a cluster, you can use these tools and run multiple workloads. Part of them, they are GVM, and part of them can be in native image, then monitor both fleets of VM containers, for example, and then each time you see a big difference from the GVM loads and the native image loads, you can get the profiles from the GVM loads and rebuild your images. So you're consuming less memory and CPU overall, but still keeping the full performance that you usually get by using the GVM mode. So there's different guides. So I said before that native image have some closed word assumption about your application, and if you use some kind of features, let's say reflections, proxies, or whatever, you need to create some configurations. And instead of, you have the ability to write them down manually, right? But we have a tool that will allow you on your Maven or Gradle workloads to generate those configurations for you. So you can run the native image plugins for Maven or Gradle, run them on your applications, and test actually basically, and they will generate all the configuration, or at least most of the configuration you require to make your application compatible with native image. The other thing is that most libraries already did this work for you and includes native image properties and configuration files as part of their libraries and jars. So we talked about the different modes and different environments. So we need to match those two together. And basically, if you're using VMs or bare metals and big application, your best option will be to use the jet mode, right? You want to consume all the memory you have, all resources, and you want to get the benefits of the optimizations that's available in GraalVM and the GraalVM Enterprise. For containers, it's different because it depends on your application. Most of the time, you may have need GVM instances because your workloads have more memory available to them. And in some cases, for you, the startup is more relevant an issue. The size of the container is a restriction for you or something. Then based on that, you can decide between the two modes. For functions, absolutely, GVM mode does not work. It does not work, basically, if you do it yourself. Some cloud providers may provide you in a way like shared VM, where you can run your functions, which is already warmed up. But the best option for this will be to use native image, because the startup time is very minimal, the memory is small, and the packaging side is also small. There are some restrictions in some cloud providers with the size of your binaries. So if you end up with size more than those, you can use some of the tools that are available for compressing executables, like UPX, for example, which may reduce your native image executable to 70 or 80% from the actual size. But then there, you need to have trade-offs basically on the speed of the memory or the hard drive you're using. That's for the workloads that you want. So every time we release a new GraalVM version, we get some new stuff in for native image and other components. So for this release, last release, some new quick improvements happened. One of the The issues people had with native image is the build time. It takes a lot of time to compile native image from GraalVM, from a jar or your JVM application. So we introduced a new mode. Besides the optimization that we do every release to reduce the size of the final binary, there is now a new mode called economy mode, right? It's not for use in production. It's basically for development time. And this economy mode will basically reduce the amount of analysis that happen on build time and produce your binary almost half the time that you usually require. If you want just to test your application locally, you can use the economic mode. Other things we provide to give you some insight on the content of your native image is part of the content that usually is part of the Graal dashboard. Basically, it will give you where most of the size or resources are used in your application. You can click and get more details, then find sometimes the sections or places of your application that you may replace instead of like loading big library to parse some content, and you can do it manually. You can replace that library with your own code, and your image will be smaller. But it gives you all the information you need, how much memory used, CPU used, and everything. So another thing from usability for developers is the new Github Action that allow you to use GraalVM in your CI/CD in GitHub without any prior setup from your side. So it can be used for Linux containers, but also there are some instructions on how to use that in Windows builds. Another new feature in this release is the availability of new builds, community dev builds for GraalVM that works on M1, basically on ARC's architecture. It's still just community at this point, and it's experimental, but people can now play with that and use that natively instead of running GraalVM using Rosetta 2 or whatever, or emulation. What else? Basically, you have a lot of tools in GraalVM platform that will allow you to do a lot of stuff in more performant way. We have VS Code extensions that, beside working with Java, you have debugging for native image, but also highlights for the languages, and even the ability to debug cross-language polyglot code. So you can get your mixed code using Java, Python, and so on, and you can skip from line to line, from one language to the other, using those extensions. You can do the same on Chrome debugger, basically debugging Python or R in the browser. And you can use the dashboard, as I said before. You have some CLI output that give you some small insight, but if you want the full details, you can use the UI for that. Visual VM, which is basically the Java thing that people use to read GFRs and so on, it has now the ability to also debug and profile polyglot languages and so on. And for language developers, the ideal graph visualizer is their thing. I guess most people are not language designers, but that's also available for someone who wants to develop a language on top of GraalVM and they want to see all the optimization for the compiler and so on. They can also develop optimization for the compiler. So GraalVM is already used in public and production loads in multiple companies. One of them is Alibaba, where they saw very significant gain from reducing the memory footprint and CPU footprint by just building their application in native image. Most of them are serverless. As we discussed, that's the best option to go with the native image, similar to CLI tools And for the roadmap, usually we get an LTS release at the end of the cycle of the year on October. And for the community, it stays supported for 1 year before we can need to move to the next one. And for EE, it stays the LTS terms from Oracle for those customers. The last releases for April they are already there. You can download them from GitHub or OTN. And you can also use the Docker images either for the community or enterprise. And you can use Luna Labs if you hesitating to install everything. You can actually try some demos directly in your browser using Luna Labs. Okay, that's it. So I have plenty of time. And that was the talk. Sure.
How does it? How does a GraalVM compiled Java application running as a Lambda compare against something like Python or Go?
So, if I understand correctly, you want to use some of compare on what term? Performance?
Basically the startup times. So cold start versus warm start. Because the issue I've got with JVM as a Lambda is the startup time, which you mentioned as well. And if you're doing that with Python, it starts up quickly on Node.js.
Yes. So, as I mentioned, one of the problems of the GVM is the warm-up time, right? Or the startup type on most of the GVMs may be seconds for some applications, but in native image is some milliseconds. For example, let's have hello world native image, it will be like 5 milliseconds or something, right? But I cannot comment basically on 2 different workloads, application developed in 2 languages, but you will see similar startup times to static languages like C, Rust, or Golang, or similar. If you use native image, basically. Was that clear, I guess?
I wanted to ask, what's the main difference between the community and the enterprise edition?
Okay, so there is the support part, right? Where the community gets support for 1 year on the LTS one. And for the enterprise, customer get up to 8 years from the standard Oracle LTS support. Another difference would be on performance. There is around like 30 optimization phases in CE, and there is around like 60 optimizations, proprietary extra optimizations that run on the EE part. There are also some specific security things, not like CE is not secure, but the EE one provides more options to enterprises to restrict memory usage for some truffle. When I talk about polyglot, this is running on top of a truffle framework, and you have more instruction and ability to limit memory usage, CPU. For some specific workloads or languages, like let's say you can run C++, right, to bitcode using LLVM and run it on top of GraalVM, right? You will get already some benefits from memory management and so on. And there is a mode called managed LLVM on the EE part, which give you more security control of the C or C++ applications. So those are the main things, I guess.
think there are no more questions, right? So.
Okay, thank you.
Very much.